Hello. Good noon, everyone. It's almost noon time. So it's a pleasure to be here and talking to all of you. And thanks, Norm, for the great introduction. I must say, we have been really lucky to have you at the center. Everybody knows it's the people behind the scene that actually get everything actually done. So I'll tell you a little bit about our work in this space. Of course, AI is, CMU has been the birthplace of AI, and we've been doing it for 60 years now. And it has only made the limelight recently. So let me just start by acknowledging first that, yes, there have been a lot of advances in predictions using AI, right? We have seen the performance of AI algorithms outperform humans in a variety of tasks shown here. Starting from, I think, around 2014, when in terms of object recognition or image recognition, right, some of the deep neural networks outperformed humans, all the way to, of course, recently, maybe starting in 2019, right, where we are getting better performance in terms of reading comprehension, summarization, speech recognition, and so on. Clearly, there are many more places to go here, and I'll talk about, of course, some of the fallbacks. But it has really permeated, and I think each one of you has been touched by the advances in AI in some way. Of course, most recently, two of the Nobel Prizes, both in physics and chemistry, were awarded to people working in AI. That's, again, testament to how much AI has come over the years. In particular, I'd like to highlight, of course, this one was purely, the first one in physics was purely, people working on statistical physics, but then taking those ideas and coming up with the deep networks we talked about. The second one, which was co-shared, but a part of it went to Google DeepMind that had come up with AI algorithms to predict the structure of any given protein. Okay? But the point I want to emphasize today is that despite the fact that you can predict the structure of all proteins now, right, there is a path to go from prediction to decision making. And that path is still very open. We have great AI that can make amazing predictions, but how do we translate that into decisions, right? How do you come up with the protein whose structure you now know of? How do you actually synthesize it in the lab, right? And yes, there have been advances in using AI for autonomous decision-making, like designing experiments, designing simulations, and so on. But I think that's where the next frontier of AI lies, in really coming up with decision-making algorithms, both autonomous, that just think about how can we take AI predictions and convert that into valid recommendations, but also thinking of the human in the loop. What if these decisions are not actually taken by the AI, or even if they are taken by the AI, have a direct societal impact? How do we think about the human in the loop? And that's what our center, the AI Institute for Societal Decision Making, is about, is really thinking of that human-centered approach to AI. So we've all probably seen several examples. Actually, it's not that AI for decision making is new. Recommendation systems have been there for a while, right? Like we are all getting recommendations from Netflix, from Amazon, Google, whatever, right, about the searches that you do. The algorithms behind the scene are modeling your patterns in terms of what you like and don't like, and then make a recommendation, right? Or they're making a decision about what to show you. Clearly, many of you probably used Google Maps or something, and again, the route recommendations, how to navigate. More maybe stylistic, but you have seen advances in game playing. That's another where the algorithms are making decisions about how to move the different pieces, what's the next move to take, and so on. Translating to, of course, more complex things like autonomous vehicles. And more recently, maybe recommendations in a language format, right? All of these are great examples, but are still somewhat toy and in a semi-realistic setting, right? So these are making decisions, but those decisions are, right, what product to recommend, maybe what to turn left or right, and so on. If we think about the real world applications, right, where we really want to use AI for decision making, and these are very complex decision making tasks, whether they be designing experiments for some material synthesis that has the desired properties. We did something similar with like cosmology. But also what the AI Institute that I'm directing now is talking about, these are all essentially centers or efforts in which CMU is part of. This one was AFRL-funded Center of Excellence. focused on materials that we have been leading. And then the NSF one that Norm just talked about, this is the most recent endeavor that really involves 10 other organizations, so really large efforts. First ones were focused on science, so a lot of just autonomous decision-making worked. But as I'm heading this AI center, to me it's becoming clear you really have to think about the human in the loop. If I'm using the same algorithms, not to make recommendations about what experiment to run or what product, but now about whether a pregnant mother should stay engaged with the health services and should follow up on their appointments, it's a completely different ballgame. You have to think about how the mother perceives the risk, how does she react to the recommendations that you are made, what works, what doesn't work. And not every mother is the same. There's a lot of heterogeneity. Similarly, we are thinking about allocation of resources. So the two use cases that our institute has are in public health and also disaster management. So under disasters, if you have different resources you want to allocate, you have to do them in a timely manner. These are life and death decisions. You have to also still be equitable. You have to reach all areas that, no matter whether, what they may be economically poor, culturally different, and so on. At the same time, making these decisions very fast. So a lot of my focus now is on looking at these domains and thinking about how can we really make an impact when we have these societal context. So the top were examples of scientific context. I think the bottom one, which the institute is focusing on, are societal impact. And how can we use AI there? So the first thing that comes to mind when we look at any of these is that failures are very, very prominent in machine learning algorithms and AI algorithms and are not going to go away, right? So a simple example of that is when you ask ChatGPT or any other large language model, right? Let's say who Tom Cruise's mother is, it'll come up with the exact answer. But if you reverse the logic, you ask who is that person's son, it has trouble coming up with it. It cannot reverse the logic, which is something we do very easily. Similarly, in other scenarios where so this example is you just write a bunch of I's, so any letter, 30 times versus 29 times. It gets the count right when you're saying 30, just because 30 occurs more often on the web than 29 does, right? And similarly for the other case where common language, right, sentences that it has seen, it tends to do well on, but things that it hasn't seen, where we will do very well if you were asked to replace every it with a, and so on, you can do it no matter how infrequent that particular language may be. So the question is, well, we will have these failures in our AI models. There's no way around it. And these failures propagate. If they are there in prediction problems, they will propagate to decision making, right? So what can we do about it? Two special challenges before we even talk about what to do is that AI failures are very different than some of the other failures we may have encountered, right? One, you cannot explain AI failures. Anybody that tells you that they have an AI algorithm that can explain why it achieved a particular decision I would not trust it, right? And I encourage you not to trust it. In fact, we have a paper where we showed that you can take any explainability metric, state-of-the-art performance, so all the white rows you see are state-of-the-art methods, the grayed ones are ours. What we did was same data set, same algorithm, right? And there's a way to artificially boost its explainability score, right? So we get exactly the same performance if you look at the F1 scores as the white rows, but you can artificially boost up any explainability metric. Metrics can be gamed. That's the bottom line, right? And in particular, that applies for explainability so well. So do not trust the explanations that any AI algorithm is giving you. It's just not possible. Does that mean we give up hope? No. You can still build trust in the decision process, maybe if not in the specific algorithm, right? And that's where we are heading towards. The second issue that comes up is you can't check AI failures, right? So you might say, oh, well, what if I can't explain it? As long as it's performing well, we don't know what goes on behind an airplane, we still get on flights. Well, if something fails, there is a procedure in place, and somebody can actually go and diagnose why it failed. Unfortunately, for AI, that doesn't exist. Right? There's no way to check the AI failures, or even if somebody finds it, that will mean nothing to you because it's a particular neuron combining things a particular way, right? It doesn't mean anything. So how do we deal with faulty AI systems, especially when we are thinking about making decisions using those? One direction of effort that goes on is, can we improve faulty systems? Sure. but there's a limit. I believe you actually cannot do that all the time. The other is, how do we live with these faulty systems, right? And the famous saying that all models are wrong, but some are useful comes to mind, right? You can still use them even if they may not be perfect. So I want to highlight some key directions that our institute is pursuing. First, more on the autonomous decision-making side, where it's just about improving the AI itself. And then on the assistive decision-making side, where now you're thinking of the humans in the loop and what you can do for those. So first of all, clearly the role of uncertainty or confidence is something that's not, I'm sure this audience understands very well. Even if you're doing stock market predictions or anything like that, you need to think about the different scenarios you can play out, right? You haven't tried everything. Even something as simple as recommendation systems, if you have never watched a movie of a particular type and the system never recommends it, you will never get, right? That may be something that you are really fond of, you just haven't discovered it yet. So you have to decide how uncertain I am about the outcome and still recommend things that may not be the most reward, that may not be predicted to have the highest reward right now, right? So you can't just rely on predictions, you have to rely on the confidence in the predictions as well. And you'll say, well, we know that. People have been coming up with confidence bounds for a while. What's new? The new part is that when we use things like neural networks, when the confidence that they produce, there are no good ways to come up with confidences. They can be overconfident like anything. Right? Here's an example, and actually applaud this person. This is from his blog. He ran a neural network on his own face, and it predicts it to be a dog with 98% probability. Right? And failures like this happen all the time. This is what explains the language model giving you those wrong prompts, because it's just confident at a wrong answer. Right? And how can we come up with well-calibrated confidence intervals for modern machine learning methods? Not your standard time series prediction or linear models that have been used, is an open question. So we are doing a bunch of work around how do we calibrate foundation models, large language, and more modern machine learning models. And how do you aggregate? Sometimes maybe you shouldn't just rely on one way of generating your uncertainty or confidence behavior. You should be aggregating multiple, and how can you combine them in a meaningful way? Another direction that's related to that is, very often, the domain that you train your models under is not the domain in which you actually deploy it. So even in scientific domains, we use simulations a lot, but then actually, you can simulate all you want and you can come up with the right settings that will give you the right material, but when you actually go in the lab, right, those things don't translate. For us, it maps to, well, we have, for example, we are working on disasters, so we have a lot of drone imagery from, let's say here, Hurricane Harvey, that happened in Houston. But now you're trying to predict what would happen when you have a different, right, a tropical, storm, Debbie, that hit Pennsylvania. We were in fact working with the Pennsylvania Emergency Management Agency that was interested in using the models we built on previous drone data on identifying different buildings and how much confidence we have that they are damaged and to what extent, which roads are closed, to what extent, and so on, right? But now you have to take those and translate those to a different setting. How can you enable that distribution shift while still coming up with reliable guarantees? How can you take that into account in the uncertainty mapping that you do? Another aspect of this is many times when you are trying things out in a simulated world that's not realistic, you may have access to a lot of data that's privileged. It's only available to you when you're simulating something, but in real life, you won't have access to that. As a more realistic, or maybe an example that you can associate with, there are lots of videos, right, of people doing things. And if I want to train a machine learning model to be able to do the same, it can look at what people did. It does not necessarily know the actions they chose. It just knows the states the video went through. So now you're trying to learn without knowing the actions, which we typically, in a simulated environment, we always assume we have access to. We see how the expert is taking the action, then we can mimic them in a machine learning algorithm. But that's very often not the case. So how can we work with when we are blinded to many aspects of the system, like not knowing the actions, not knowing the states fully, and so on? All right, so from autonomous to assistive decision making, now we think about how we can help the humans. I feel like we have come completely, the other side of the pendulum, starting from expert systems way back in the 80s to now systems that are completely self-supervised, right? They are learning to finish the next word in a sentence, there are a lot of sentences out there. It can completely train that on its own. They are learning to play against each other and get better. And there's no human involvement as compared to the expert systems, which were completely human dependent in terms of what rules to use. So we have come the complete other way, and what we are missing is the human. That's why things, when we make the AI predictions or recommendations using it, they don't align with the human interests. So how can we bring back the human goals and objectives into our machine learning models, right? One aspect of it is, first, how do we even elicit from humans some feedback that's relevant? The large language models, ChatGPTs, and so on, if you have heard of it, they are based on this technology called reinforcement learning with human feedback, RLHF. That's also based on, they train their model, large language model, purely on text, and then they go ahead and collect data from users about their preferences, thumbs up or thumbs down on whatever the response was. And then they fine-tune their model to align with the human judgments. But very often it's hard for humans to say, right? Like, do I like one thing versus another? Because maybe I like one thing, one response, because it's more fluent, easy to understand, but then the other one is actually more helpful or useful, right? We face a lot of such challenges when we are talking about, right, like giving recommendations to pregnant mothers. There are certain things that are easy to do, right, but may not be as useful. So how do we even extract? They may say, I like this over this, but on this particular criteria, not all the criteria together, right? So we are developing methods to elicit and leverage such human feedback. Another part of it is that there are competing objectives very often, right? You want to increase access, but also the decision has to be timely. It also has to be equitable. So how can we understand how humans, first of all, do these trade-offs? Because I can come up with like some combination of these different objectives, give it to the algorithm to optimize, but if it doesn't align with how the human is trading these things off, right, it doesn't work. So that's why we have social scientists on the team who are working on, can we look at past decisions of human decision makers and infer how did they trade off things like access versus equity and so on. Can we learn that, and now can we inform the machine learning algorithms using that as well? And another important aspect is, like, how do we, when we are thinking about not just AI in isolation or just AI coming up with recommendations, giving them to the humans, but the human is really involved and you're trying to solve a task together, what should the human-AI interaction look like? Should I first let each of them make their independent decision and then merge the decisions somehow? Should I show the AI recommendations to the human, right? Note that an important part is anytime you make an algorithm makes a decision or recommendation and shows it to the user, it can influence how the user thinks itself, right? So there are these feedback loops that are present when you are using AI recommendations, that anytime you make a recommendation, you are actually changing what the human may have wanted. So how do you take these into account? So we are looking at different ways in which AI and human can interact with each other. What are the user factors as well as societal factors that can influence adoption? Right? So for example, you can have a technology that does great. Only take the example of clinical imaging, right? Everybody said you will replace the, all the people who are radiologists and so on. But why hasn't it happened? Because there's a gap. There's one place where you have the technology to do something, but then adoption requires somebody has to be accountable for the failures. So now we are trying to think about in fact, MITRE is a partner that's actually developing a use case. It's looking at all AI adoption use cases, whether the AI was adopted or not adopted, and trying to infer what factors, such as like accountability, how important it was, how high risk the decision was, and can we elucidate a framework around what are the important things that lead to adoption or not adoption, and which interaction pattern is the most useful under which set of constraints. Finally, I mentioned, you can get human feedback and align with it, but who do you align with, right? There's a lot of heterogeneity amongst the people, right? There are conflicting opinions. We are clearly aware of that. We are a very divided country right now, unfortunately, that people have very different opinions. And how do you, one option is, of course, in like the maternal intervention case, we can actually make things very personalized. So you can make recommendation personal to each person. But there are nevertheless social decisions that need to be made, like resource allocations in disasters. Right? So how can you make them while adhering to, how can you achieve some social welfare, right? While respecting whatever utilities every individual might bring. So there's a whole intersection of social choice theory with AI that we are seeing right now. a lot of research going on in that direction, including in our institute as well, where even standard large language models, they treated all the thumbs up, thumbs down as coming from one meta user, right? But now they are actually starting to think, well, that's not the right thing, right? If I have a lot of males telling me, right, giving me the feedback versus, female or people with different cultural backgrounds, you get very different responses, and they may not agree on what they think is the right output. So how can we come up with, using some social welfare notions, combine them with the AI decision-making objectives? So that's all. I wanted to keep it short, but give you time to maybe ask questions. These are just some samples of the kind of problems we are working on in this institute, more focused on the societal aspects, but previously more also on the scientific, just autonomous decision-making aspects. Thank you.
Hey, thank you for a great talk. I'm a student here at CMU focused a lot on this exact space. I'm curious how you consider the ethical trade-offs from getting fully into the paradigm of prescription of a decision, i.e. imagine you open a device and it says, hey, you ought to do this, versus just recalling the information and retaining full agency of the human in the loop to then make the decision, i.e. just as an informing agent or as an actual prescription agent to aid decision making.
Yeah, I think this gets to the interaction mechanism I was talking about. How should the human and the AI interact together? And it depends on what the ethical question is. The ethics in maybe recommending a product to buy would be very different than the ethics under a disaster scenario. So that's where we are exactly coming up with this list of what are the factors that influence then which way you should interact. So it's not just about improving the individual decision-making algorithm itself, it's about thinking of the entire pipeline and thinking about what data goes in. You shouldn't be getting feedback only at the end, you should be getting feedback even at the beginning, right? So how does the entire decision-making pipeline look like? And the factors that come in, how high versus low risk it is, what does the accountability look like in that particular domain, consequences. So coming up with a framework for how those factors mediate what the interaction should look like is the important part.
Hi, Aarti. Great talk. I have a question. There's a lot of people in this room that are actively or considering deploying AI models in their companies in the private sector. And what guidance or methodologies can you offer for those of us outside the Institute to really consider the societal impacts of the AI that we deploy?
Yeah, it's a great question. So I think that's why some of the things I chose them that, one, if you are using an AI model in your, whatever pipeline, very first thing is, if you're using it for decision making, do not forget about uncertainty. Very often people just take the predictions and go with whatever is predicted to be the highest, let me deploy that, right? And the second point being that you have to look at the entire pipeline, right? You can't just think about what will be the effect of changing one particular decision. You have to think about how I'm interacting with the user throughout, which means even what is the data that's going in, right? You should vet the data, vet the algorithms, have stakeholder participation at every stage, and then think about deploying it. So once we have this framework out, which I think a lot of it is going towards what does that framework look like for the human-AI interaction? So we'd be happy to release it. We are just 1 year into it. If you have examples of use case studies for when adoption succeeded or not, share with us. We are building this database and actually training a model around it that will help us elucidate what all these factors are, both at the societal level, at the organization level, that lead to a perfectly great AI technology not translating into adoption. I think those are going to be probably the most meaningful. So yeah, whether you can share or not, I think just listing out those factors for your own each individual use case is so important. And that's another thing I want to stress.
Hi, thank you so much for the talk. You mentioned eliciting human feedback was one of the big things that you're working on. Probably everyone here knows Entrepreneurship 101 is elicit stakeholder feedback, and there's a whole bunch of tools for how you do that. I was wondering what AISDM is doing that is from that toolkit, and also what we as entrepreneurs should be doing that is from the HCI Human-Centered AI Toolkit.
Right, so I think first is just thinking about what form you can get the feedback in, right? Very often people say, oh yeah, I can just get thumbs up, thumbs down, as I just told you, like not many people will agree on it. So we are looking at how do you do aggregation of feedback from diverse users. That's one thing. So that's where the social welfare choice approaches are helpful. We are also looking at, sometimes people cannot just say, I prefer this over this. I prefer this under this criteria versus I prefer another thing under a different criteria, right? So how can you take that feature-specific feedback into account in our machine learning algorithm? So we have approaches designed for that. If you're interested, I'm happy to share those with you. These are just some examples of the kind of things. And beyond that, I think you also have to think about, it doesn't have to be just like thumbs up, thumbs down kind of feedback. It could be now, especially with large language models, it can be open text feedback, right? So you can have that feedback. You can have demonstrations as another type of feedback. We are also looking into these alternate types, ways in which you can engage with the humans and bring that feedback, and how to scale it up is another option.